an awful lot of what we, I guess, as humans, unless we see it or visualize it, it's like not our problem. So this is why I really like this picture. It's just because you can't see it doesn't mean it's not there. Okay, so I'm going to try as much as I can to focus, because a lot of our research in the bay would have been in Galway Bay, but I'll also touch on other research that looked at sources and different pathways and how they get to the marine environment. So while they're not directly from Galway Bay, it will be equivocal across a lot of different systems. And we'll come back to this picture a little bit later, and you might look at it on a different perspective than you do now. I'm going to start right at the very basics. So microplastics, what exactly are microplastics? So what we're looking at, the two things I guess you need to kind of remember is that they're synthetic, okay? And their size ranges from 1 micron to 5 millimeters. And in that context, if you remember your pencils back in the day, the top of a rubber on a pencil would be 5 millimeter diameter. So that's kind of the upper range of our microplastics. And you're talking about the tip of a pencil being 1 millimeter. So to go down to 1 micron, we're talking about less than a red blood cell. So it's something we can't visually see. So that's why I think this graphic is quite nice. We have our, going from our macroplastics, which you may have thought I brought all my rubbish today, but we have lots of different types of plastic sources here that we'll talk about a little bit later. And if you want to interact with them, if you turn them upside down, it shows you how long it'll actually take them to decompose in the environment. So some you might be surprised with. So this is the kind of area that I'm working in your large and your small. So actually what I might do, sorry, no, the camera woman is not going to be happy. I'm going to pass these around. These are the upper range limit of microplastics. The ones in black are from astroturf pitches and playgrounds, and I'll touch on them, and the others are from beaches. So just to give you a kind of a context of what, and these are the larger ones that we're kind of looking at. Okay, so when we talk about nano, which we won't be touching today, it's completely really, really small and smaller than a blood cell. Okay? So I'm going to cover a little bit more of the technical details before we get into the fun part. So we can divide microplastics into two parts. One is called primary microplastics. So these have been designed to be a specific size. Okay, they've been designed largely to be between 1 and 5 mils. And this is the bill that we had. This is the microplastic bill you may have heard of in the legislation that we introduced. And that was to prevent the intentional addition of these primary microplastics. So now you can't make a product in Ireland and add microplastics intentionally to it. Okay, it's the first step. It's a good step that we're moving in the right direction. And where this came from is essentially the power of the people when you think about it. There was this movement, Beat the Microbead, that came from looking at all these kind of exfoliants and different products that you would have, and they actually had microplastics in it. Now, they were fantastic if you wanted soft skin or the glow in your cheeks, and it used as an abrasive. The issue was they were designed in plastic to put them into these, and of course when you apply these, they're going to be washed down the sink and into our water systems. So this essentially movement put pressure on our policymakers and moved towards introducing the legislation here and across Europe. So now it's rare enough to find any products that will have microplastics in it as regards cosmetics. They've been given a timeline that they have to get rid of them. Okay, so that's great, but this is only one element, and this is our primary microplastics. This is actually a little bead. Sorry, I get excited. We don't find too many of them in the marine environment. That's a little blue microbead that we came across. Yeah, she was the one that pushed it forward. Yeah, absolutely. And she was great, in fairness. So before, when they used to be advertising, you'd see things like polyethylene, which is a polymer, which is a synthetic plastic. They would be actually advertising that there used to be microbeads in it. But this is the way, because of this, gone forward. Now you're going to see a lot of things. Our cosmetics are microplastics free, so they're using it to promote, actually, we're much more environmentally friendly. And there's a lot of different alternatives like sea salt that you can do that do just as good a job. This is, I guess, where it is more problematic, and it's not something that we can literally say, okay, we need to ban secondary microplastics. So secondary microplastics are the breakdown of our larger plastics. So synthetic clothing, textiles, bottles, anything, laptops, anything that have plastic in it can essentially be broken down, and they will cause these secondary microplastics. And what happens when they break down, they form these kind of fibers, films, fragments. So they break down into smaller elements. And once they're less than either 5 meters diameter or length, then they're considered a microplastic. Okay? The good news is they are doing research, so I'm going to throw a little bit positives as we move along, so you don't all leave here very worried. So they have found out if you use fabric softener in your washing machine, it'll reduce the amount of plastics that'll come out of your fleeces and your tops. Because when you think about it, washing process is quite abrasive, and obviously if you've had a top for quite a few years, you can see it's getting faded and it'll get worn, and that's the plastics coming off it. But by adding that softener, it's not as abrasive, and it does reduce the amount of plastics, because you're talking about per wash 700,000 microplastics. That's a lot. So I'm going to go back, I'm going to, as I say, have those three different contexts. We're going to look at the sources, the pathways, we look then at kind of in the environmental fate and where it's coming from, and then we look at some more positive news. So even, I guess, for me talking there for the last few minutes, it's quite apparent that there's a huge amount of sources of microplastics. So I kind of put in this to give you kind of scale. It's from everything from companies to indoor particle emissions, consumers, production, and we'll have a look at agriculture, wastewater treatment plants, processing industries. I mean, there's a whole realm, and then there's ones within the marine industry like fishing, tourism, and all that. And even the road markings on the road come off as sources, and paint is a source. It's in synthetic microplastic when it chips away. So it's a phenomenon. So it's not surprising that we do find it pretty much everywhere that we do look. When we look at the term marine litter now, I left this in just to be very officious, and this is the definition that the EU came across. It's any kind of persistent manufactured or processed solid material that's deliberately, intentionally or unintentionally added. Now, why I did this, when we talk about marine litter, we think of a whole scale of things, but of all the marine litter, 70% is actually plastic. And no matter what size, that's invariably going to break down. So it can be breaking down by the sun, by waves, by abrasion. There's lots of different ways that actually plastic can break down. And if you get a chance to look at the materials on the table here, you'll see how long it'll actually take them to break out or to completely get rid of them. This I find is an interesting one, and this is the kind of study we were looking at to see, and I think a lot of people aren't aware of it. And one of those little glass tubes that I passed around has what they call infill, these rubber granules here. Everyone has seen at least an AstroTurf, maybe not everyone has played on one, but they're phenomenal. They're like for the west coast of Ireland when our weather isn't great sometimes and we get that bit of rain, kids and adults and everyone can still go out and play in pitches. So socially and economically, they're of a huge value to communities. Where we have, I guess, a slight problem is these rubber granules are end-of-life tyres. So the tyres in your car that can no longer be used, they can grind them down. And let me guess, these are between 1 and 5 millimetres. So now they're considered microplastics. Now, it would be fantastic if we could keep them on the pitch. But if anybody has kids or been on a pitch and checked your car after they've got into your car, been on Astro pitch, they've taken half the pitch with them. So the granules travel on clothes, boots, and if there's not barriers around the pitch, they can actually be blown out or washed with water so they can get into the environment. So these are kind of some of the different pathways that we've looked at. We did this kind of Instagram to see how potentially they can leave a pitch. But I mean, it doesn't leave a lot to the imagination. We did a study and we know that the smaller ones travel further. But then we didn't follow a player and see how far they drove from a pitch and their clothes get washed and into a washing machine. So there's lots of different ways that they can potentially get into our aquatic environment. So we were working at looking at mitigation to how can we retain that. Now, the good thing is Europe is moving on this because their end-of-life tyres have toxins in them that we don't want anybody really to be exposed at. Now, they're at a very low level, but still no level is an acceptable risk. So they're looking to ban it. But as I said, there's such a high social and economic benefit to it that there is debates between the countries of how they're going to manage this. There's not an alternative at the moment because in pitches you want to make sure that those playing is player safety as well. So they're designed to allow the player to play in replicate turf, but also that if they fall, they're not going to be completely destroyed. I'm sure you've seen people, if they've fallen on like hockey pitches, they can get quite severe. So this will actually be quite flexible and not kind of get injured. So if we move on, construction industry, a lot of construction in Ireland at the moment. There's no containment. Again, it's about they're doing a lot of this outside, open air. We've got a lot of pathways that it can travel. Like, I mean, your PVC, your polypropylene, your wastewater kind of pipes, all of those, they're being sawed to fit different dimensions. And in the sawing them, you're getting loads of microplastics on the ground, and that can travel, again, with wind or outside. And I mean, like, I live in Dublin, so there's a lot of construction going on around me at the moment, and different sites are different levels of cleanliness. But no matter how clean they are, there's going to be elements of microplastics escaping. So this is quite a worrying one, because you're looking at much higher levels that are escaping, and we're looking again at mitigation measures. Now, this is source of microplastics. This is just in the marine environment, just to kind of give you a scale of things. So your synthetic fibres, your textiles are one of the biggest kind of sources, or ropes in the marine environment are sources. But the car tire particles are another very big one, and that's again from your astroturf, from driving. So every time you brake or you accelerate, your car is wearing off little particles, and those are microplastics that are being released. And surprisingly, a lot of people will forget about road markings. So the road markings have to be maintained, and obviously if they're being maintained, there's bits of them that are coming off as well. We've kind of touched a little bit, so it's on sources, we're moving into pathways. So there's several. I mean, there's some very visual ones. Any kind of a natural disaster, a tsunami, anything like that, if you look at the wreckage, it's bringing rubbish from one area to another. Invariably, there's plastic in that. Invariably, that's going to break down. And that's going to be a pathway for pollution, including kind of plastic pollution. You've got your wind, rain, all of these can transfer. So I guess keep in mind that microplastics are between 5 mil, and then ones you can't see down to 1 micron. So they can travel in the air quite freely, and we won't see it, except if you're in my house and you can see the dust. You can probably see the plastics going around. But there is 1 or 2 areas I'm going to have a look at here. We're going to have a look at agriculture. We did a study on agriculture. We looked at rivers. I shouldn't touch this, sorry, it's waving. And we looked in the marine environment, so currents and waves, and ways that we can actually move these particles around. So what we want to see is, where are they ending up? Can we mitigate against it? Can we monitor that to see what we're doing is actually lowering the amount of plastics that are there? Now, one thing I guess I want to bring your attention to is not all plastics are the same. Okay, so we have lots of different what they call polymers that will make it up. Some, and they're made for different reasons, some for longevity, some for fire retardant, so they'll have lots of additives in it, and that will affect their densities. Okay, so when we have different plastics of different densities, they can, in the marine environment, because we have salt, they can actually be found at different levels naturally. So once you put them in, they would actually naturally fall out of different ones. So the heavy ones, PVC, are heavier than water, and they would sink. Now, just to add an element of fun to that, or not so much fun, once you put anything in the marine environment, it gets this kind of biofilm on it. It's like in Ireland, once a field comes up for sale and someone can build a house in it, everyone's in there. You know, everyone wants to get in. You put something in a marine environment that they want to settle on. There's not a lot of rocks on the seafloor. There's a lot of sediment. So you put on something that you can build a house on, you're going to get, within 24 hours, something on it. And then there'll be competition on this. By these little hitchhikers, like here, the barnacles, they are going to make this heavier. So that now can sink into a different area within the ocean. So essentially, while I haven't divided here, all of the collection of different plastics can be found at all different levels throughout the ocean. And you'll see that why that's important a little bit later on. I don't know if you're aware of resin numbers, but these 1 to 7 here, they're on every plastic that you pick up. It'll have a triangle on it, and it'll tell you what it's largely composed of, and that will actually tell you how recyclable it is. Okay, 1 and 2 are usually the most recyclable. They're the ones that the recyclers want. They're the most easy to recycle. Clear plastics, again, are much more preferable than something that's been dyed. So you'll see a lot of consumers now, or producers now, moving to remove the colour of the plastic, but actually putting wrapping on it instead, which is much more preferable for the recycling industry. So let's move on to like our pathway. So one thing we looked at is, we looked at wastewater treatment plants, but also in relation to agriculture. So wastewater treatment plants were never designed to capture microplastics. In saying that, they're doing a fantastic job. You can get up to 90% retention now, depends on the level, it could be only 60%, but you can get up to 90% retention, which is phenomenal for something that's never designed to address them. Now, here's the fun thing in Ireland. I don't know if there's any farmers amongst us, but I'm from Tipperary, so we tend to do a lot of farming down there. And what a lot of our farmers do is use the biosolids from the wastewater treatment plants, and we spread it on the land. So what we've used to capture those microplastics in the settlement process of the wastewater treatment plants, we now take and we spread it on the land to fertilise it. So what we do... Okay, so...
I don't know any water treatment plants in Clare that are selling the biosolids that farmers have access to. So is that actually happening?
Oh yeah, but it's not to be... I guess I'm from premier agricultural country. I don't know they need any amount of fertiliser to do some of the land up here. Oh yeah, no, they would, because it's much cheaper and there's a lot of nutrients in it that they can use and they spread on it. So as my husband is from Dublin would say, when you go down the country, that lovely country smell would be taken fertiliser. And sometimes they would do it. They'd use that as well, yeah, but they do use spread biosolids as well.
Is that from the organic waste?
Yeah.
Where to do that?
Yeah, but you have to think this is something that has been done and was never seen a problem. It's only now that we're discovering microplastics that we realise, okay, this mightn't be such a good thing to do. Do you know, the more we do research, it wasn't done out of, on purpose. You know, they saw it was a good way to recycle, to use solid waste that was, getting the crops grown. So what we did was looked at agricultural fields where there was a record of spreading biosolids on it. And we said, well, let's have a look and see, what's happening there. But because we want, our kind of questions in our research was, can it get to the rivers? Can it get to our waterways? Because we were, that was kind of our overall question in our projects. But obviously, we don't want to treat land with plastic, so we did some experiments first to see. So we set up this, and this is kind of a rain gauge here. And what it is, you can control the level of rain, because obviously it rains a lot in Ireland. We want to see if we put plastics on the surface here. So, to example, if plastics were spread on the land, would they actually transfer vertically down through our tubes? Interestingly, we couldn't get the plastics to go beyond the surface. Now, this is only preliminary studies and there's a paper on it, but more research needs to be explored in that, but we couldn't get them to vertically go down. So we went and said, well, what's actually happening in the field? So we took cores from the field, and what they found was the microplastics were retained in the top 35 centimetres, which is essentially the area that's ploughed. Okay, so when they took a core and looked at it, this is the area that's ploughed, that's kind of broken up. So anything that lands here would be mixed in with the plough, which makes sense when you're ploughing the land. So it's found, but it isn't, they didn't find it below this, which would kind of make sense in this experiment, why it wasn't going down in kind of tillage fields. So another thing they looked at, well, right, does the slope or the rainfall, does that have an effect when it's spread on the land? So they did a kind of a slope and a rainfall simulation. And this is a table that you can change the slope. They put grass in it. And again, you can have your rain coming down through here. And what they found is when there was grass growing on the table, it reduced the export potential of microplastics. Now that's quite nice, yeah.
Do the cattle eat microplastics?
Yeah, if they're on the grass, yeah.
So then it starts all over again, or gets into the meat?
Well, now, I would, maybe that's a question for the Q&A. I personally haven't been convinced of studies where microplastics can transfer across membranes. Nanoplastics, maybe. So if you're talking about macroplastics here, as humans, we could eat a bit of plastic and we would be able to pass it out. And so would kind of cows. So there is studies exploring that, but at a different level, at the nanoplastic level. And I haven't seen the results of that yet, but there is. They would definitely, if they're on the grass, they're not going to clean it and then eat it, you know. So, oh, sorry. So the slope wasn't seen to have a huge influence, and neither The rainfall, slightly heavier rainfall, it was seeing it, but once you put grass in, it was retaining it. So there is the acres program that they have now. They're encouraging grass verges and around the edges of fields. So that essentially will stop our microplastics going into our waterways, which is really nice. So it'll have a dual effect: increase biodiversity, but also kind of contain the microplastics. I guess rivers, it's no surprise that if it goes into the river and it can float, it's going to travel with the river. If you have a lot of rainfall, it can actually dilute the amount of microplastics that there, or you could see an increase depending what's along the side of the river. So if you're going through a city and it's washing road runoff or anything that into the rivers, you could potentially have a lot of higher levels in it. Now, not to go into too much detail, but like you're going to have areas of river that's fast flowing, and then you're going to have areas that will be much slower flowing. So you will get areas where it's kind of like low energy. You'll get plastics deposited there, but generally they'll push them through the fast flowing areas. And this is where we kind of get into then the environmental fate. So now we have, it's past, now we're going to come across, obviously I could probably put environmental fate, we could have put a few cattle or cows in there to add to the dimension of it. But we were looking within the riverway. So looking just at a typical food web here for a river, and this is from the Slaney River. Like at the top of it would be your Asian otter. So they would eat everything down here, your sticklebacks, your trout, your eels and your minnows. And down here we have your what's called benthic macroinvertebrates. So benthic, they live in the floor, whether it's a river or whether it's the sea, they live on the soft sediment or the hard sediment here. And these are little critters here, like I guess like you'd have earthworms on the terrestrial land, you have all these that will live in the river. So we looked at each of these levels to see, did we find evidence of microplastics? And surprise, surprise, yes, we did. So about 70% is what you're finding across a lot of different things, 70% instance. Now you have to remember that we're looking at these, so it's a snapshot. The next day you might find a much lower level. So it depends what's in the water, whether they're feeding and where those sources are coming from.
So sorry, what's the 70%?
70%, so if I looked at one species of fish, there's a chance if I had 100 that 70 of them would have microplastics.
And what was not 1 in 6 then?
So so if I took 100, so the average would be, so if I took 100, 70% would have microplastics. But if I looked at 10, one could have 1, one could have none, one could have 7. So you could have a range of microplastics within any species. So it's not, they don't seem to be accumulating them. So they are eating them, but like us, are able to pass them. Okay, so we're only getting a snapshot of what's there. And if they haven't eaten and their gut is empty, you might find none. If they've just had a feed of maybe invertebrates, where all of these might have 1, you could have 7 in it. Or you might have a random one that'll have 15. But on average, it's about 70% incidence, and then there's relatively low levels because they can pass them through. So in this way, while it is environmental fate, it's nearly another pathway. Okay, because they're not staying within the animal, they're still passing, and they, in the case of otters, they're pooping them out, and we didn't kill any otters in the making of this. We looked at their poop. So we looked at their scat and we identified plastics that were in it. Okay, so that's what we would have done. So they would have been taking it from the river and now leaving them along their different paths. And
Was that 70% of the animals as well? Or?
yeah, I think it was about 70%, yeah. Like it's quite high. Like you might get a sample and you might get 100% incidence. In others, you might get down to 6. But on average, and this is looking across pretty much worldwide, there's an awful lot of, it's a relatively high incidence that's been recorded. Now, I guess one thing, I now want to move on a little bit. So if you're looking where they live in the environment and you look at river samples, so these are different sites. So these are just R to S3, it's just the code that we used. But just in this river sample, they got quite high incidence of plastic. And remember, this is only, I took it now, so this is only reflective of what's there now. But they also took those invertebrates here and they looked at the levels. Now, we can put different feeding groups, we can divide them up. And just say a filter feeder is something that takes particles or food from the water. So if you've got a lot of particles in your water that are plastics, you can see here it's reflected in your filter feeder. So they're going to have a lot more available to them. So it makes sense that they reflected a lot more. Whereas in another site where we had much lower levels, our filter feeders were much lower here again. And then you'll have predators and ones that are scavenged, and they're just going to take what's in the sediment. But these that are going to be much more reflective of kind of the water. So if I had the sediment profile here again, we could look at the different feeding types and how that reflected what they were eating. Is that all right? So now we're eventually getting to Galway Bay. So now we're moving, and our Corrib River has come into the estuary. Here is Mutton Island. Here, this is where the river comes down. This is the city. We wanted to see, so when the river comes out, as a river meets an estuary, it'll spread out and it'll essentially drop its load. So once it goes beyond the Claddagh there, out that fast area, once it reaches past that, it'll start to spread out and it'll start to drop its load. So we wanted to know, looking at the ebb and the flow of the tide, we plotted our stations to see, will it have a higher level of plastics in the sediment compared to the rest of the bay? And yes, it did. Okay, so there's more likely to find microplastics around estuarine areas, sediment, than you would even in riverbeds or in a bay as a whole, because you're getting all the contamination is coming from the whole catchment. Another area we're interested in is, we looked at surface water within the bay. So we looked at currents and we looked at wind. Well, we largely looked at wind. Another study in University of Galway had the currents done for us, which was great. And we took all our different samples here and we looked to see how they were related. So a lot of surface winds are kind of tie in with the current, but they change quite regularly. So we got it for the days we were sampling to see, was it reflective? And what we found is actually the currents are much more reflective of what was found in surface waters. So in Galway Bay, it comes in the South Sound here, it travels along here, comes back out and goes out the North Sound. And there's what they call gyres, so there's little circles of water at different places, so you get unusual animals and fauna. So the hotspots maybe near the coastal area or near the city, and then you could have a gyre here that's capturing the water. So we found that currents were kind of driving that area. And if you move on to look at impacts, so a lot of impacts that you'd have seen, that would have been shown on telly or newspapers, or tends to be more the macroplastics. So you're talking about entanglement, ingestion of turtles eating plastic bags. So they were very visual, and they're purposely used to get people, to look at it and say, actually, we're doing damage to the environment. Whereas if I started putting up all these little creatures, they're like going, oh, here, sure, we don't like them anyway. What are they doing? You need something that's more charismatic, that can actually, people can, I suppose, relate more to a dolphin than they can to a little maggot. So just to, again, I guess visually, and while these are macro litter and seaboards, there is some microplastics in here. And what they're finding is at sea, they're not being able to distinguish them between food, and they're interacting with them. You get a lot more now beached birds that are dead. And what's happening there is that they're trying to feed up, maybe if they're traveling or migrating, they're kind of trying to fill their stomachs and build up their fat reserves. Unfortunately, when they eat plastics, that fills their stomach, and they think they're full and they stop eating. So they can't pass the plastic. So what's happening is these poor birds are actually starving. They're not building up the nutrient reserves they need, and they're actually starving because they have that full feeling, but unfortunately, it's not food that they're eating. Am I okay to go for another few minutes? I'm nearly there, so it won't take too much longer. So sources, pathways, we looked at commercial species, because obviously this is, if you're going to eat them, people are interested in, well, am I eating microplastics? Good news is, keep eating fish, you're okay. They will have it in their stomach, but hopefully you gut the fish. Well, in Ireland, we gut the fish, and that takes out your microplastics. Now, it's a delicacy when you go abroad to eat the stomachs of fish, so I can't guarantee if you go abroad and it's served up to you, you won't have it. But again, with prawns, and prawns have their intestine and their gut is like that little black line that runs along it. So if you are shelling prawns yourself, just make sure you remove that, because that's where you'll find your microplastics. Now, when I say that, you could be, I think it's 1 to 7 is kind of the range, but if you're having a dozen prawns, then you multiply that by 12. But as I said, if your body is healthy, we can pass it.
Oysters?
Yeah, I was going to say oysters and mussels, we tend to eat them whole. So we do tend to eat microplastics when we eat mussels and that. Now we have a study gone, and what they do is they actually depurate them. So if you buy them in a store, they'll have put them in clean water because they want to empty their stomachs so you don't have that gritty taste when you chew them. So if you have a gritty taste, there's still stomach there, but they leave it usually for about 42 hours and that clears them. But the studies that we have, you need to leave, I think this one they said you need to leave it an extra 12 hours to completely get rid of it, but it does get rid of the majority of microplastics that are in it. Now, it depends. If they're in a clean tank, they could be taking the plastics back in, so you could have that kind of error. And again, with the mussels we were seeing. And what was interesting with these mussels that my student was looking at, I don't know if you're familiar with Booterstown in Dublin. It's a marsh, it's very polluted. There's a mussel bed there. You definitely wouldn't be eating the mussels out of there. It's like a class C. I wouldn't anyway, and hopefully no one is. But those mussels were just as efficient, if not better. They'd 3 times or more the amount of plastics, but were able to, within that 42-hour period, expel a huge amount of them. And in that site, which is exposed to much more the city life, there was microbeads, whereas mussels that are in the west coast, there's not so much anthropogenic impacts. We have wastewater treatment plants. This one, there's a polluted river that is going into it, and you wouldn't find as many microbeads. I think in the 10 years I've been, or more that I've been looking at, maybe half a dozen microbeads we found in Galway Bay, which is good. Not that my students, when they're looking and they say, I didn't find any microplastics, I get excited. And they're like, oh, no. And I'm like going, it's a good if you don't find it. So on the scale of things, when you're looking worldwide, we've now reached 1,288 marine species that have recorded microplastics within it, and that's 1,500 species in total. So looking at Galway Bay, and one thing we're trying to do is set up kind of a monitoring program with the Marine Institute, is we have checked all the different, we've taken sediments from all across the bay to see the kind of levels that are there, and there's a huge variance here. So what this graph says, so this is the microplastics per grams dry weight, so it goes 0 to 30. So in some sites you can have up to like 25, or in another sample you might have only 5. So there's a huge difference around the bay as the number of microplastics that are kind of there. But in comparison to bays across the world, Galway is pretty good. But in fairness, we'd really expect it to be. We've got the whole Atlantic Ocean that's washing it out. So we wouldn't want to be the levels that they're finding in China, and bays like that are like phenomenal. So it is relatively clean, but we want to keep it that way. So we are looking at spatial and temporal benthic sampling to inform kind of the future monitoring going forward, to see if we put in mitigation measures, if we stop doing X, Y, and Z, is it at least not increasing the number of plastics that are in the bay? So sediments as a kind of a fate is one of the best places to kind of look at. I put this in because this is the deep sea, this is the Porcupine Bay, and I'll show you it on the next slide here. It's not Galway Bay, it's a good distance from Galway Bay, it's out here. And I was really hoping we got the opportunity to work up samples that we would find none. We did. We found it in 75% of samples, even out in the Porcupine Bank. It's not a huge surprise when you look at, this image was taken last night. That's how prepared I was. Last night at 11 o'clock when I was finishing my presentation. This is the marine traffic. That was the live marine traffic that was out in the seas at 11 o'clock last night. Okay? Now what's interesting, see this curve here? So if you look at the traffic pathways, and these are the sites that we would have sampled, there is fishing vessels, there's transport boats, so there is, even that far away, they are potentially exposed to marine sources of pollution, whether it's from tourism, whether it's from fishing. And even at this site, we would have found discarded fish nets, whether they were discarded or whether they broke off. You would find them down there, and those ropes are going to break up and give your microplastics. Are we finished now? I promise.
That's the rubbish we find the beach cleanup is from anytime when it's all loads have been fishing boat litter.
Yeah.
So.
And like what I found funny, like an awful lot does come from land, but my God, there is a lot of pollution going on at sea. There's a lot of sources that you can get there and that can be broken down. So onto some good news, that we are working hard to find solutions and transition towards like a sustainable future. We have our G20 action plan for litter. I know a lot of it is talk, but it's the first time it's actually moving, it's in that realm. We have a UN Ocean Conference in 22. We now are working on this legally binding treaty on plastics. Okay, so this is currently going on at the moment. There's a high seas treaty that includes plastic pollution for the first time ever mentioned in anywhere there. I'm part of a scientist coalition, and what this is, scientists all across the world, and what we want to do is make sure that it's fact-based evidence that's going towards this treaty, that they are pushing it as far as they can, that they're using all the facts. So there's negotiations actually in Paris this weekend, and there's a group of us gone over there, and they will try to, we have fact sheets on different areas that have come from experts all across the world to see, can we make sure that that information is disseminated and get our message across and get as strong as possible treaty on plastics that we can going forward, because it is kind of the only kind of solution. Now, a big element of our research is communication and dissemination, trying to get out and reach as many different types of bodies and people as we potentially can. So, like, I was at the Oireachtas for the microplastic bill. We did a policy document for microplastics in the marine environment for Europe. We have a microplastic perception document just to show, actually, are people aware of what's actually happening. We've developed a secondary school taster course for transition year students looking at sustainability, plastic pollution and global citizenship. We now have a new project, Waves of Change, that we're trying to promote development and behavioural change. We do online seminars which are free to people to come to. We go to schools. We're currently developing an open access MOOC just for 3 weeks, just to do not just plastic pollution, but actually ocean pollution. So we're doing as much as we can possibly do to try to reach as many audiences. And I think when people become more aware, you know, and that's what you want to kind of educate them. So before the sun goes down here on Galway Bay, we're going to take a last look at this lovely picture I put at the start. And you'll probably look at it in different eyes than you did when I actually started, and the amount of plastic pollution you can actually see from it, where first you visually might have looked going, oh, this is beautiful down the Claddagh and the river. And now, you know, I think by educating people, it opens their eyes to see, you know, what is out there. And well over my time, I would like to say thanks. And this is all our funders.